Hello, and welcome to the CCNA Routing and Switching course offered by SimplyLearn. The previous lesson focused on Cisco's Internetworking operating system. In this lesson, let us look into the network architectures, wireless access, and troubleshooting of Cisco's Internetwork. Let us begin with the objectives of this lesson in the next slide. By the end of this lesson, you will be able to describe network architectures for small office, home office, and small to medium-sized businesses. Explain considerations for wireless access to a network. Follow a frame or a packet through an internetwork for troubleshooting purposes. Let us first look at network architecture in the next slide. Network architecture refers to the way devices are connected to form a network. This is not the same as network topology. Topology refers to a specific network's layout. Architecture refers to the general approach to designing a network. Different business requirements dictate different network architecture. For small office, home office, SOHO environments, the architecture is simpler than in enterprise environments. There may be an all-purpose device instead of a separate router, switch, and firewall. For example, for home use, most routers are really a router and a switch combined. There is less redundancy, which makes configuring, maintaining, and troubleshooting the network simpler. Usually, one subnet is used for all devices and static routes are used for routing. There is no full-time network administrator. In the next slide, let us look into small office, home office architecture. The characteristics of SOHO architecture are as follows. The router, switch, and firewall functions are combined into one all-purpose device. The device acts as a Dynamic Host Configuration Protocol (DHCP) server for the PCs. The Internet Service Provider (ISP) provides one Internet address. Therefore, the device also acts as a DHCP client of the ISP. In other words, the all-purpose device obtains the Internet address from the ISP and provides addresses for network devices. The device has a default route to the Internet. This means that if the device has no specific route for a destination IP address, the packet is sent to the Internet. Network Address Translation, NAT, is implemented to allow network devices to reach the Internet. In the next slide, let us focus on small to medium-sized business architecture. Here it is seen that there is no longer one all-purpose device. The switch and router functions are separated. As the number of network devices increase, a router no longer provides enough interfaces to connect them all. Therefore, a switch is implemented. The router uses firewall software. In this architecture, a standalone firewall device is normally not deployed. Note that in the figure on the slide, there are two connections to the Internet. One through a tunnel and one straight to the Internet. This does not mean that there must be two physical connections to the Internet. This separation can be implemented with software. Let us continue our discussion on small to medium-sized business architecture. The characteristics of a small to medium-sized business architecture are as follows. Depending on the business, there may be a site-to-site VPN that encrypts traffic between this business and its suppliers and/or customers. There are varied types of traffic on the network. Network management and/or monitoring software is installed to monitor the status of the devices and traffic. Wireless access can be implemented in any architecture. In the next slide, let us look at how wireless access works. The devices must be connected for a network to function. The connections can be wired or wireless. In wired connections, the transmission signal passes through a copper cable, whereas in a wireless network, it passes through the air. A wireless network may be used to connect to the Internet in a business of any size. Typical PC wireless access requires an access point. This is where the signal becomes a part of the wired network. Access point software or hardware may be included in a router or an all-purpose device. Wireless is not a secure medium. Transmissions are easily intercepted. For business purposes, it is highly recommended to use VPN software. Let us move on to a new topic, documentation. In the next slide, let us look at a larger network to see how frames and packets are sent and received. Data flow can become very complex and fast. Documentation is important for understanding the flow of data in the network and helps in troubleshooting any network problem. Documentation includes a topology and a detailed listing of IP addresses. Most importantly, documentation must be kept up to date. For example, network changes usually occur when there is a problem with the network. Assume the problem is fixed. Documenting changes seems to be a lower priority item while fixing the problem. Hence, it is delayed. Often it is skipped completely. The next time there's a network problem, the network administrator will look at an outdated documentation and it will be difficult to troubleshoot the problem. Hence, updating the document is important. In the next slide, let us discuss following the frame or packet. The topology given on the slide is meant to reflect interactions in a production network more accurately. In the middle of the topology are three routers. Note that there are different subnet addresses for each router interface. On either side, a router is connected to a switch. The switch on the left is connected to two PCs, and the switch on the right is connected to a PC and a server. Here it is assumed that the end devices are in the same subnet, 192.168.1.0/24 for the two PCs, and 192.168.2.0/24 for the PC and the server. In the next slide, let us look into the table of addresses for devices. The table on the slide shows each device and its interfaces. For each interface, it also shows the device to which it is connected. The third column shows the IP addresses and prefix length. Note that the switches have no IP addresses because they are at layer 2. The last column shows the MAC address of each interface. This table, or one like it, is important documentation for your network. To create the table, you can use Microsoft Excel or a software program specifically designed for network documentation. Let us continue our discussion on following the frame or packet in the next slide. Appropriate IP addressing and naming is important to troubleshoot a network. In the topology, the hostname RTR1 is attached to 192.168.1.0/24 network. Note that router 1 has network 1 in the third octet. This makes it easy to remember. For RTR2 and RTR3, this convention was not followed. A better scheme would be to switch the names of RTR2 and RTR3. Then RTR2 would be attached to the 192.168.2.0/24 network. Note the addresses used for links between two routers. Only two addresses are needed, so /30 networks are chosen. This is the most efficient use of IP addresses. All these /30 networks are assigned a subnet in the 192.168.0.0/24 network. If there are problems with 192.168.0.0/24 subnets, the network administrator knows immediately that these interfaces affect a large number of users. This signals a major network outage. Let us move on to the quiz questions to check your understanding of the topics covered in this lesson.